So we're back to this problem, all right? If you didn't figure it out, what I want you to do is pause the video and do a prime factorization of every number over here on the right. If you do that, you'll probably see it pretty quickly, all right? And then compare it to prime factorizations of numbers over here. Okay, so pause the video and try that. If you do that, you would realize that these numbers are composed only of 2s and 5s. So only if we are dividing up that grid of 10 by 10, the grid of 100, only if we're trying to divide it up into things that are divisible by 2 or 5, are we ever going to be able to give people equal amounts of pieces, right? As soon as I try to divide up into thirds or ninths, right, there's always something left over. Sevenths, you know, how do I divide a 10 by 10 grid up by 7, right, and give everybody the same amount and have it work out perfectly, right? That doesn't happen. So the rule is that the only way that 1 over n will terminate if the prime factorization of, oh, I butchered the word factorization. There we go. Only if the prime factorization of n contains only 2s and or 5s. Right? So like over here, I might have 2 in my prime factorization, or I might have a 5 in my prime factorization. But as soon as I introduce any other factor, like a 3 or a 7, you know, any other prime factor other than 2s and 5s, I will repeat. So a little bit of reminder of what we've done in the past. So remember, we learned that in the system of real numbers, we had our real numbers, right? And so that was, you know, if we looked at the whole entire box, right? This is all the real numbers. Remember, we had our rational numbers, which are numbers that can be written as the ratio of 2 integers, and all repeating decimals are rational. Every repeating decimal has a fraction equivalent. Irrational numbers over here were numbers like pi or radical 2, right? Numbers that could not be written as a fraction, which would mean that they would be a decimal that goes on and on and on forever. Okay, and so because of the way our calculators work, right, our calculators, depending on your settings, you can change the settings, but I think the maximum you can get a decimal to go out on your calculator is maybe like 8 places. All right, so we have no idea how many of our fractions actually are repeating decimals, and we don't really ever see, because of our calculator, that sometimes we get the maximum length of a repeat end. All right, and so notice 1/19th, and I attached a document I hope you'll look at. 1/19th is a digit with an 18 number repeat end. All right, and the reason that happens is as I'm dividing by 19, there are 18 possible remainders. So I hope you will see that on the handout that I've scanned. I circled all the remainders, and you can see that I go through every remainder 1 through 18 before I start to repeat. So what we want to say about 1 over n, and remember, we're talking about fractions in lowest terms, because you might say, wait a minute, 3 over 6, that repeats, or that terminates, but you said anything that ends with a, you know, the denominator is a 6, because that has a factor of 3. You'd say, well, wait, you had that on our, you know, the 6 would be over here on our repeating list, right? But 3 over 6 terminates. That's because this is not in lowest terms. All right, so let me specify when we're talking about the rule we just gave and this rule here, we're talking about a fraction that's in lowest terms. All right, so what we want to say about 1 over n is that the longest possible repeat end for 1 over n is n minus 1 digits long, right? And if you were asked me like an obvious question, well, how do you know if it's going to be the longest possible or if it's going to repeat sooner? That would be a whole other lengthy discussion, and a whole bunch of different things from number theory would come into play there. So that's not a question that we're going to explore in this video clip. But that would be a great thing to explore. What are the numbers that give me this longest possible repeat end?